All right, here's problem number 8 from section 3.8 as requested. This is again a proof. It's coming in the section where you prove triangles congruent using a new way, which is hypotenuse leg. So I got to prove right triangles here in order to prove that I have congruent triangles. So what I have here, I'm going to write my given. Step 2, I'm going to look at this picture. I'm trying to prove that ACF is isosceles. I'm trying to prove this big thing is isosceles. Well, like we say every day, there's 2 ways you could do this. You could either prove the base angles are congruent. That would make it isosceles. Or you could prove that 2 sides are congruent. So you could do one or the other. So let's look at what's given and see what's going to be easiest to prove that this big triangle is isosceles. So it says BD is perpendicular to CF. GE is also perpendicular to CF. CE is congruent to DF. And BC is congruent to GF. Okay, so looking at this, it looks like the easiest way to do this is I'm going to prove these little triangles on the side congruent, and then corresponding parts of congruent triangles are congruent. CP/CTC will help me prove that these little angles are congruent. Okay, so that's going to be the goal. Well, using the new theorem that we learned today, I can do this because what I have here, by subtraction, I can say that CD equals EF. And then looking at these little triangles, those are going to be congruent actually by hypotenuse legs. So to do that, I need to take a couple preliminary steps before I do that. But I'm going to say that what I already said, which is CD is congruent to EF. But that's by the subtraction property. If the same segment, which is in this case DE, is subtracted from congruent segments, CE and DF, then you get congruent differences. So this is straight subtraction property. Step 3 and step 4 are going to be to prove that the 2 triangles are right triangles, because I cannot use HL, which is what I want to use, unless I have right triangles. So I need to do this. So I'm going to say that angle BDC and angle GEF are right angles, first of all. The reason would be because if perpendicular lines, then right angles. And then I can take step 4 to say that triangle BDC and triangle GEF are right, because if a triangle has one right angle, so if one right angle, then right triangle. Okay, so use what you got right triangle. So now I'm ready to go. I can use HL. I have the hypotenuse, I have the leg. I got the hypotenuse right here. BC and GF were the hypotenuses of each of the little triangles, and I got the leg right here. So I'm ready to go. I can say triangle BDC is congruent to triangle GEF by HL. All right, well, I'm not done. I still need to prove the big triangle is isosceles. So what I can do to do that is not that these triangles are congruent. I can prove angle C is congruent to angle F. The reason being, corresponding parts of congruent triangles are congruent, CP/CTC. And now I can say that the big triangle ACF is isosceles, right? Because if base angle is congruent, an isosceles triangle. Okay, so I hope that helps. It's a pretty straightforward HL postulate problem, and I hope that helps you with your homework.